Imagine this traveller, your presence here isn't random. Something in the quiet between the stars has guided you something older than our first whisper into the dark. For more than a century, our world has been leaking stories, songs and static into the void. And now we wonder, what if a distant mind finally heard us, a signal repeating near 1420 megahertz, the frequency of hydrogen itself. A fragment of another star drifting inward, silent and deliberate, passing too close. A light that blinked once and vanished, and beneath all of it a single lingering question. What if someone finally picked up "Stay a While, Traveller"? Let's drift through the silence together. In the stillness of a late-night sky, Traveller imagined 4 small observatories watching the heavens with a patience humans rarely manage. They are part of the Asteroid Terrestrial Impact Last Alert System, Atlas machines designed not for drama, but for quiet vigilance. Every 30 seconds their cameras breathe in another piece of the night, gathering the slow, steady heartbeat of the stars. Nothing shifts up there without leaving a trace. Stars remain faithful in their places. Galaxies hold their ancient silence. Only an object that moves against this tapestry earns attention like a single drifting ember in a vast and motionless sea. Algorithms sift through these images with a calm, methodical grace. They are caretakers of the sky, comparing one moment of stillness to the next, searching for the faintest deviation from what should be. Atlas was built to protect us, to find the small stones that wander too close, stones that could become threats. But on this particular night at 3:42 UTC, one of its observatories found something that did not belong to any familiar chapter of the solar system. In the constellation Microscopium, a small point of light drifted with improbable speed, nearly 3 arcseconds per hour, too fast for a distant asteroid, too controlled for random debris, a quiet anomaly, but anomalies, Traveller, are where the universe begins to whisper new truths. Atlas paused its automated routine just long enough to flag the object for deeper scrutiny. Soon, Pan stars in Hawaii confirmed the same motion. Moments later, the Zwicky facility in California agreed. 3 separate instruments under 3 different skies were watching the same unexpected visitor make its gentle passage. The Minor Planet Center in Cambridge received the data by dawn. Equations unfolded, orbital parameters hardened into meaning, and one number refused to be ignored, an eccentricity greater than one, the unmistakable signature of an unbound trajectory. This was no child of the sun. This was something born elsewhere, wandering freely between stars until chance, or something more purposeful, brought it into our view. By the time astronomers spoke of it that morning, they did so in soft voices, as though raising their volume might disturb the fragile truth emerging from the calculations. The designation followed quickly. Through me, Atlas, the 3rd confirmed interstellar visitor. Another traveller from some other star carrying a piece of a story we could barely imagine. Yet 3 Atlas behaved differently from its predecessors. Oumuamua had tumbled unpredictably. Borisov had breathed like a classical comet. But this new visitor moved with an almost serene regularity. Its brightness rose and fell with a rhythm that suggested not chaos but intention, a measured rotation as if it turned itself gently to meet the light. Spectroscopy added another layer of quiet mystery. There were hints of outgassing, but they were faint, almost withheld. The surface appeared too red for simple rock, too structured for ice alone. And so astronomers did not rush toward explanations. They simply watched, letting the object reveal itself at its own pace. Radio pulses from Goldstone reached the visitor, and came back with reflections that seemed oddly smooth in places, oddly angled in others. The echo suggested surfaces that felt less like chance and more like arrangement, but hints, Traveller, are only ever hints. Then the James Webb Space Telescope opened its golden eye. It saw thermal patterns that did not follow the simple curve of a stone warmed by sunlight. The temperature rose and steadied where it should have fallen. It plateaued where it should have spiked. It behaved as though moderated not by nature but by design. Thin structures perhaps, materials responding to light, something managing its own heat. To some the unease was immediate, to others the fascination deepened. But here in the quiet of silent cosmos, we choose neither fear nor urgency. Instead, we choose wonder without conclusion. The universe is not here to alarm us. It is here to remind us of our smallness, our curiosity, and the beauty of encountering something we do not yet understand. Tonight, as you let your mind drift with this interstellar visitor, remember, not every mystery needs resolution. Some are meant to be observed gently from afar. Some are here to widen the space inside us for awe. It's all right to not understand. Sleep, now observer. The cosmos will keep its silent watch. In the weeks after Thrizi Atlas was first detected, astronomers continued to observe it with the quiet discipline that defines their work. The object moved with a steadiness that did not resemble the behaviour of typical asteroids or comets, and yet nothing about it demanded alarm. Its light curve showed a gentle rhythm, and its path through the inner solar system, though unusual, remained predictable. For most, it was simply another anomalous visitor, rare opportunity to study something forged in a different stellar neighbourhood. Then, on the 15th of July, radio telescopes turned toward the object. This was routine. Comets and small bodies often interact with plasma or solar wind fields that radio observatories can measure. But what these telescopes detected was not noise, not plasma scattering, not background interference. Instead, they found an unexpectedly narrow, remarkably stable signal near 14.20.4 MHz, a frequency intimately tied to the hydrogen line, long considered the natural crossroads for interstellar communication. The Very Large Array in New Mexico registered at first a faint, clean tone rising just above the noise floor. Greenbank in West Virginia confirmed the detection within hours. FAST in China, with its immense listening surface, captured it with striking clarity. 3 independent facilities separated by continents and technologies all heard the same narrowband signal coming from the same region of sky, moving precisely with the trajectory of 3I Atlas. The immediate interpretation was cautious. Narrowband signals do occur in nature. Masses in star-forming regions emit similarly tight spectral lines. Certain plasma instabilities can generate coherent emissions under the right conditions, but those phenomena do not track hyperbolic interstellar objects across the solar system, nor do they align themselves so closely with the mathematically significant hydrogen frequency. The signal behaved with an almost unsettling fidelity. It drifted in frequency, but only by the exact amount predicted by Doppler shift from the object's motion, no more, no less. It faded when telescopes pointed away. It returned the moment they aligned again. This coherence made terrestrial interference unlikely, and the simultaneous detection by geographically distant arrays effectively ruled out local contamination. What remained was the simplest, though not the most comfortable, scientific conclusion. Whatever produced the signal was co-moving with the object itself. But astronomers did not rush toward exotic explanations. Instead, they approached the phenomenon with scientific restraint. They verified their instruments. They recalibrated antennas. They compared signal to noise ratios across independent delta pipelines. Science does not thrive on dramatic leaps. It thrives on slow, methodical accumulation of confidence. Yet as observations continued, the signal began to change. Not dramatically, not in a way that demanded immediate reinterpretation, but subtly. A clean tone gave way to faint structure. A stable carrier began to exhibit regular interruptions. Small clusters of pulses emerged from the background, separated by precise and increasingly recognizable spacings. It was prime numbers at first, 2, 3, 5, 7, 11. Simple but unmistakably deliberate mathematical sequences, the same structure humans once used to demonstrate intelligence in the Arecibo message of 1974. Still, the scientific community remained careful. Prime numbers appear in many natural processes, resonant modes, quantum systems, even in the organization of biological structures. Patterns alone do not constitute evidence of intention. Statistical rigor would be needed before any extraordinary claim could be considered. Nevertheless, the emergence of ordered sequences near the hydrogen line broadcast by an object travelling on an interstellar trajectory was enough to shift the conversation from curiosity to deep analysis. Throughout this period, the world continued on with its usual cycles of morning and night. Most people remained unaware that a signal, steady, coherent, and mathematically suggestive, was drifting through the quiet of space following a visitor from elsewhere. But in observatories lit by dim red lamps, astronomers listened with increasing attention. They charted the drift of the carrier. They mapped the pulse sequences. They compared them against known astrophysical sources and found no ready analogue. Yet even here within the strangeness there was no sense of threat. The signal was faint, non-invasive and scientifically elegant. It carried no energy capable of influencing Earth. It broadcast no information that suggested urgency or intention. It was simply present, calm, structured and persistent, like a scientific phenomenon that had waited a long time to be noticed. What mattered most was not the speculation that surrounded it, but the methodical steps taken to understand it. Science at its best is a practice of patience. It does not force answers. It gathers measures, compares, and accepts uncertainty as part of the process. And in this case, uncertainty was not a barrier, it was an invitation. So the astronomers continued to listen. Not with fear, not with expectation, but with the steady discipline that defines their work. A narrow-band signal from an interstellar object is unusual, but unusual is not impossible. In the quiet space between explanation and mystery, the most honest choice is simply to observe. Tonight, traveller, let this understanding settle gently. Even in the presence of the unknown, the universe remains orderly. The laws of physics do not tremble. The sky does not shift. A signal at the hydrogen line is only a new point of data waiting to be studied with care. And if meaning exists within it, science will reveal that meaning in time. Until then, it's all right, simply to listen. As the days passed, traveller astronomers around the world shifted from curiosity to a quieter, more focused form of attention. The signal near the hydrogen line continued to repeat with the same steady discipline that characterized 3i Atlas itself. It did not brighten. It did not waver. It merely persisted, matching the object's motion with mathematical precision. In science, persistence is often the first sign that something deserves deeper study. And so, with the calm patience of those accustomed to long nights beneath steady stars, the community began to examine the broader environment in which this visitor had appeared. For within weeks of 3i Atlas's discovery, other observatories began flagging similar fast-moving objects, first one, then another, and then several more. Each appeared from a direction near the constellation Lyra. Each followed a hyperbolic trajectory, and each moved with a velocity inconsistent with debris gravitationally bound to the Sun. Individually, these detections could have been anomalies. Collectively, they suggested a pattern. The Catalina Sky Survey reported 4i, Linear detected 5i shortly after. Amateur astronomers using far smaller instruments, but guided by increasingly refined predictions, began contributing detections of their own. The night sky, once a place of slow celestial rhythm, now carried a faint sense of organised movement. Yet even here the scientific response remained measured. Patterns require verification. Coincidence must be distinguished from signal. And the universe, vast and indifferent, often produces alignments that look intentional, simply because we are so good at noticing structure. Still, the data accumulated. These objects did not arrive from random directions. Their trajectories converged within a narrow 15-degree cone. Their perihelia clustered near the orbital zone of Earth. In celestial mechanics, randomness tends to express itself broadly. But here the motions tightened around a region of space that suggested more than chance. Dr. Alan Fitzsimmons at Queen's University Belfast carried out a formal statistical analysis. His team produced simulations, randomized catalogues and Monte Carlo trials to test whether such alignment could arise naturally. The probability they obtained something near 1 in 50 million did not constitute proof, but it did qualify as an anomaly worth exploring with seriousness. Yet despite the strangeness of these trajectories, nothing in their motion suggested malice or hazard. Their speeds ensured they would not remain long in the inner solar system. Their distances from Earth remained safe. They interacted with sunlight, solar wind and gravity in ways consistent with objects of relatively small mass. No unusual acceleration was recorded beyond what had already been observed in 3i Atlas. Their presence was unexpected but not threatening. What puzzled astronomers more was their diversity. One object, 4i, produced a light curve so elongated it resembled a thin rotating needle. Another 5i flickered with the irregularity of fragmented material. A smaller 1/6 behaved almost like a sheet, its surface deforming subtly as it turned through sunlight. These behaviours were unusual for natural fragments whose shapes tend toward more predictable distributions. But unusual does not mean impossible. Nature produces its own catalogue of rare geometries. Tidal breakups, stellar collisions, and interstellar weathering can all carve matter into unexpected forms. The question was not whether these shapes were natural or artificial, but rather what they indicated about the environments from which these visitors originated. As radio astronomers extended their observations, they noticed something else. Each of these new objects emitted narrowband signals. Each signal hovered near the hydrogen line, but none matched the others exactly. Some showed small modulations, some drifted with slightly different periodicity. One pulsed in brief bursts across a range of frequencies known informally as the waterhole, a quiet region of the spectrum bounded by the hydrogen and hydroxyl lines. These differences complicated the interpretation. A single anomalous radio source might be dismissed as plasma interaction or equipment noise. Multiple sources, each distinct yet consistently narrowband, called for care but also deeper inquiry. The signals were not identical, but they shared a conceptual proximity as though governed by related physical processes or similar environments. The simplest explanation remained astrophysical. Narrowband emissions can arise under specific plasma conditions. Interstellar particles interacting with solar radiation may produce coherent structures, and the hydrogen line is so fundamental to cosmic chemistry that even natural processes can cluster around it. Still, the synchronization of these emissions across multiple hyperbolic objects drew attention. The universe rarely repeats itself in such coordinated ways unless there is an underlying mechanism guiding the repetition. Throughout all of this, the scientific community avoided the temptation of premature interpretation. Instead, researchers built databases. They compared spectra. They analysed Doppler drift. They worked across time zones, sharing observations not because of urgency, but because of the quiet recognition that these objects represented an opportunity to understand the interstellar environment with a level of detail previously impossible. Nothing about these detections changed the night sky. The stars remained in place. The planets continued their orbits unaffected, and Earth, unaware of the faint signals passing through it, went about its rhythm of days and nights. But in observatories where astronomers spent long hours with coffee cooling beside keyboards, the data slowly accumulated into something beyond curiosity, into a persistent, gentle question. What does the galaxy contain that we have not yet accounted for? It is possible, traveller, that all of these visitors are natural, shaped by stellar processes we barely understand. It is also possible that some share a history, or an origin point, or a trajectory in ways that hint at structures larger than our current models can encompass. Science allows both possibilities to exist in parallel until evidence tilts the balance. And so, rather than rushing into conclusion or speculation, astronomers remain in the space between studying, measuring, comparing, and accepting that the universe has always been more complex than the frameworks we build to describe it. It's all right to not yet know which interpretation is correct. Tonight the objects continue their path, the signals remain faint, and the sky keeps its silence as it always has. In the soft quiet of late nights at observatories, traveller, there is a rhythm to scientific work that feels almost tidal. Telescopes pivot detectors, hum servers, process streams of starlight, and beneath that steady routine, astronomers began to ask a question that felt more philosophical than technical. If these objects come from interstellar space, when did they first notice us? This was not speculation, but a matter of geometry, physics, and time. Signals travel at the speed of light, no faster, no slower. To know when something might respond, one must first know when it could have heard. And so, researchers turned their attention not toward the objects themselves, but toward Earth's own history of transmission. In a sense, they began listening backward in time. Dr. James Chen at MIT's Haystack Observatory led this reflection. His team reconstructed humanity's electromagnetic footprint from the 1940s onward, not for drama, but for clarity. They mapped the power direction, frequency, and reach of every major transmission Earth has ever released into the cosmic dark. Television signals, military radar, deep space planetary scans, navigation beacons, accidental leaks from countless technological systems, each wave expanding outward like a ripple on a pond. By the early 1970s, those ripples had reached roughly 50 light-years from Earth. The region contains dozens of nearby stars, some sun-like, some dim red dwarfs, some with known planetary systems. If any civilization lived there with instruments more sensitive than ours, Earth would no longer have been silent to them. They might not have heard our words or intentions, but they would have noticed our presence, a sudden flare of artificial radio brightness on a planet that had been quiet for 4 billion years. To calculate what those potential listeners might have detected, Dr. Chen's team analysed transmitter power and antenna design in careful detail. Television broadcasts, though iconic, were weak, detectable only a handful of light-years away with plausible instruments. Military radars from the Cold War era were stronger, but their narrow beams swept the sky unpredictably. The clearest, loudest transmissions came from a narrower category: planetary radar experiments, Arecibo, Goldstone, Evpatoria. These colossal systems once sent megawatts of power into space, bouncing signals off Venus asteroids, the Moon. Their beams were focused enough that across interstellar distances the signal would still be coherent. If another civilization had a receiving dish even vaguely comparable to ours, they could have detected these pulses as unmistakably artificial. But detection is only half of the question. The other half is timing. Suppose a star system 50 light-years away received our broadcasts in the early 1970s. If a response departed immediately, travelling not at light speed but at a fraction of it, could it reach us in 2025? The mathematics, while simple in form, carried a quiet weight. Many trajectories, even at 10 to 20% of the speed of light, converged on the same answer. Yes, not proof, not even strong evidence. Simply possibility, which is where science often begins. Dr. Sarah Martinez at the Harvard-Smithsonian Center for Astrophysics explored this further through statistical analysis. She cross-referenced the inferred origin directions of the interstellar objects with humanity's own periods of loudest transmission. Using Monte Carlo simulations to avoid misinterpretation, her team found overlap significant enough to warrant further study, though far from conclusive. Other researchers countered with caution. Dr. Robert Hayes at the University of Arizona reminded the community that humans are pattern-finding, beings capable of discovering structure in pure noise. With hundreds of nearby stars and decades of transmissions, coincidences would inevitably arise. His team ran parallel simulations demonstrating how easily false correlations could emerge when data sets are large and flexible. This interplay of possibility and restraint became a hallmark of the analysis. One team proposed a pattern, another tested it, another attempted to break it. What survived was not hypothesis but method, a way of thinking that protected wonder from drifting into assumption. The temporal structure of the arrivals, however, continued to tempt deeper inquiry. Objects appeared in a loose sequence. Some arrival windows aligned with notable epochs in human broadcast history, the rise of powerful television transmitters, early space-age radar systems, the first commercial satellite networks. It was impossible to know whether this reflected cosmic accident or meaningful parallel. To probe this further, Dr. Lisa Johansson at the SETI Institute proposed what she called the echo hypothesis. The idea was simple: if the objects were responses, natural or otherwise, to Earth's electromagnetic signature, their arrival times should reflect the combined delay of light travel distance and interstellar transit. She created a model, assuming plausible velocities, and weighted it using Earth's transmission intensity over time. The curious part was that some of the predicted arrival windows aligned with observed detections. But here too, the scientific voice remained steady. Alignment is not intention. Correlation is not causation. Patterns in the sky do not always indicate patterns in minds. Astronomers approached the results with a kind of meditative patience, recognizing that the galaxy often arranges matter in ways that resemble conversation, even when none is occurring. In that sense, the universe is like a vast library of coincidences, most of which mean nothing at all, and a few of which invite a closer look. The signals themselves, faint and narrowband, offered more data to sift through. Some carried sequences reminiscent of mathematical structure, prime numbers, numerical progressions, or patterns that seemed almost algorithmic. In previous generations, such features might have been interpreted as clear evidence of intelligence. This time, researchers moved more slowly, aware of the long history of mistaking nature's complexity for deliberate design. Each analysis included statistical safeguards. Each claim was tested against simulations of random noise. Hypotheses were pre-registered to avoid subconscious bias. Independent teams analysed the same data through entirely different methods, and through that process something subtle emerged, not certainty, not revelation, but a kind of scientific stillness. A recognition that the signals, whatever their origin, had taught humanity something valuable about itself, that we are capable of listening with discipline rather than fear of questioning, without leaping to conclusion of holding both wonder and doubt in the same quiet breath. Tonight, Traveller, the data continues to be studied. The signals remain steady, drifting softly with the motion of their sources. No answers have yet arrived, only possibilities, and it's all right to not understand what any of it means. In the quiet hours of the observing night, when even the control room hum softened into a kind of contemplative stillness, the first signal from 3i Atlas arrived without ceremony. It was not loud, not dramatic, not even immediately recognisable, just a thin, persistent tone hovering near 1420 MHz, the hydrogen line. To astronomers, that frequency has always been more than a number. It is the softest universal constant, the heartbeat of neutral hydrogen, the quiet breath of the cosmos itself. If any civilization wished to be heard across the dark, this would be the frequency they might choose. Yet the universe produces it freely, and often a natural whisper permeating interstellar space. That ambiguity made the new tone neither comfort nor alarm, just something to observe with patience and respect. The signal appeared only when telescopes pointed directly at 3i Atlas. At Green Bank, FAST and the Very Large Array independent receivers caught the same thin line each instance, drifting with the object's motion, each returning the same narrow bandwidth and the same surprising stability. No satellite, no ground transmitter, no atmospheric anomaly matched its signature. The Doppler shift synchronized perfectly with the object's trajectory. Even so, astronomers resisted premature interpretation. The hydrogen line attracts coincidence. Plasma tubes, magnetospheric arcs, and interstellar shocks can all sculpt narrowband radiation. Nature is capable of harmonies we do not yet fully understand. So the scientific community did what it always does in the face of the unknown. It listened longer. They checked for interference. They repeated calibrations. They fed raw data into independent pipelines, each built differently to catch different kinds of artifacts. Every test returned the same quiet verdict: the tone was real. It was extraterrestrial and it moved with the object. Yet none of this by itself implied intention. The universe often displays structure without motive. Patterns do not always mean messages. And so night after night observatories collected the signal as they would any faint cosmic phenomenon, with careful discipline and gentle curiosity. Outside the scientific world, however, the whisper spread quickly. Leaks escaped the usual containment. Headlines sharpened the story into shapes the data did not yet support. Some spoke of messages, others of replies. But inside the observatories, where the midnight air smelled faintly of electronics and cold aluminum, the tone was simply another feature of the spectrum, something to be measured, catalogued and understood without haste. Amateur radio listeners soon joined the effort tuning home-built antennas to the hydrogen line, catching static noise, and on rare occasions faint patterns that might or might not have originated from the object. Thousands of people scattered across the world found themselves listening to the night sky, again, a collective act not of fear, but of wonder. The situation shifted when additional interstellar objects, 4i, 5i, 6i, and others began to emit their own tones near the same spectral region. They were similar but not identical, slight offsets. In frequency, modest variations in amplitude, brief bursts in one case, steady carriers in others. The differences complicated simple explanations. If these emissions were natural, why would their characteristic be similar yet distinct? If they were unrelated, why would all appear near the hydrogen line? But science does not assume meaning where uncertainty remains. Researchers turned to VLBI arrays linking radio telescopes across continents, to triangulate origins with micro-arc-second precision. Each signal traced back to its respective object. None originated from background space. Still ambiguity remained. Perhaps this was a class of interstellar phenomena, not yet recognized charged surfaces interacting with solar wind, exotic dust aggregates emitting under solar irradiation, or structural configurations responding to thermal extremes. Physics often reveals new behaviors when pushed far beyond familiar environments. The universe rarely repeats the same design, but sometimes echoes it. There is poetry even in coincidence. The public imagination moved faster than the data, yet scientists remain grounded, speaking softly into cameras and conference rooms, reminding viewers that detection is not dialogue, and that a tone, no matter how graceful, does not speak intention unless intention is proven. Journalists asked whether intelligence was involved. Astronomers replied with probabilities and certainties, and the quiet discipline of skepticism. As one researcher put it, if the universe is speaking, it will speak again. If it is noise, the silence will reveal it. And still, the signal continued steady, thin, unfailing. Beyond the technical debates, a cultural shift began to unfold. People stepped outside more often at night, looking upward, not in fear but in contemplation. Radio clubs revived old equipment. Children drew pictures of faint objects moving through star fields, imagining stories the data had not yet told. University applications in astronomy surged. A sense of shared inquiry spread, a recognition that even a faint tone near the hydrogen line could remind humanity of its place within a wider, older, quieter universe. In the end, perhaps the most remarkable part was not the signal itself, but the stillness it created, the awareness that the cosmos, in all its vast indifference, had produced something subtle enough for Earth to notice. Whether it was physics or something more intentional remained unknown. Yet the patience to observe, to measure, to refrain from leaping into conclusions that was its own kind of contact. A dialogue not of words, but of attention. Tonight the signal still drifts soft as breath, steady as a heartbeat in the spectral dark. It tells us nothing definitive. It demands nothing from us. It simply exists, a quiet feature in a quiet universe, waiting for us to understand what we can and to accept what we cannot. And it's all right to not understand. Tonight the stars will keep their silence. Sleep now, observer. The cosmos will keep watch. When additional visitors began to appear across the automated sky surveys, first one then another still, the scientific world did not react with alarm, but with a widening sense of quiet astonishment. Interstellar objects had always been expected to be rare, perhaps appearing once every few decades, if at all. Yet here they were, 4i Famfkes, 6i, each moving on trajectories that mirrored the strange elegance of Thruis Sa Atlas. Each one arrived not chaotically from different regions of space as natural wanderers should, but from a loosely coordinated region near the constellation Lyra, as though following paths defined not by randomness, but by some distant alignment of forces. The numbers were precise, and precision carries its own kind of poetry. Probabilities fell into place like faint stars joining a pattern. One chance in 50 million that so many hyperbolic visitors would approach from the same corner of the sky. One chance in tens of millions that their perihelia would cluster within the narrow range that intersected Earth's awareness. Such numbers did not imply intention, but they invited reflection. They whispered of patterns whose origins were not yet understood, of cosmic arrangements too subtle for human intuition to grasp without long contemplation. In the observatories, astronomers watched the light curves of these newcomers unfold. Their rotations were strange, too stable, too regular, sometimes too complex. One brightened and dimmed in long gliding intervals as though shaped like a needle. Another flickered like a thin rippling sheet. A smaller visitor seemed weightless, almost fragile, responding to sunlight in a way no rocky fragment ever had. These were not the blunt, irregular forms of natural debris. They were not impossible, but they were unfamiliar, and because they were unfamiliar, they invited care. Spectroscopy whispered fragments of composition, carbon compounds of unusual complexity surfaces that absorbed and reflected in irregular ratios, occasional hints of metals arranged in ways that defied straightforward geological explanation. But nature is inventive. Interstellar chemistry does not obey the expectations learned from the limited materials of Earth. The possibility of exotic natural formation remained open, and open possibilities are where science breathes. Radio telescopes added their own quiet layers to the story. Each new visitor brought its own variation of the narrowband tone. Some pulsed, some stayed. Continuous, some shifted slightly in frequency as though marking distinct internal processes. None of these variations were dramatic enough to suggest meaning, only enough to prevent them from being easily dismissed as the same phenomenon repeated. If they were natural, their diversity reflected a shared origin shaped by different conditions. If they were artificial, their diversity suggested intention without revealing purpose. Researchers built models. They tested hypotheses. They argued gently across conference tables and video calls the way scientists do when evidence is still too delicate to support firm conclusions. Some described the ensemble of objects as debris from a distant stellar event, perhaps fragments of a disrupted system pushed across interstellar distances. Others proposed more structured frameworks, a sequence of visitors that might represent a single multi-part phenomenon. A few cautiously raised the question of coordination not as an assertion but as a pattern, worth examining with open eyes and closed assumptions. Meanwhile, the public leaned into wonder. Skywatchers stepped outside on cold evenings and followed tracking maps published by observatories. Artists painted long arcs of glowing visitors drifting through the solar system. Teachers in dim classrooms explained parabolic trajectories to students who watched rotational light curves like they were lanterns drifting across a dark ocean. And children, with their natural gravity toward imagination, asked whether someone might be sending these objects an innocent question, with no evidence to support it, but with a kind of purity that adults sometimes forget to allow. Scientific caution endured. Uncertainty remained the equilibrium point. Data continued to accumulate, shaping a landscape of probabilities and unanswered questions. Very long baseline interferometry revealed faint course corrections that could be natural or engineered, depending on how one interpreted small deviations from expected paths. Statistical analysis revealed temporal echoes between Earth's century of radio leakage and the possible launch windows of the visitors, an alignment so striking that it drew both fascination and skepticism in equal measure. Some researchers extended the timeline tracing Earth's expanding radio bubble like a growing sphere of influence. They mapped which stars would have intercepted our strongest transmissions. They calculated when those signals would have arrived. They compared those dates to the estimated launch times of the visitors. The overlaps were curious, but curiosity is not conclusion. Other researchers cautioned against the look elsewhere. Affect the human tendency to find patterns in any large dataset simply because our minds are wired to search for meaning even when none exists. Through it all, the sky remained silent in the way the sky has always been vast, patient, indifferent to interpretation. The objects travelled their paths with no regard for human anticipation. Their signals continued steady and faint. Their geometries rotated in slow, deliberate rhythms that might reflect physics or precision, or some combination of both. And as Earth watched, humanity found itself revisiting an old truth that wonder does not need answers to justify itself. The universe does not hurry to reveal its intentions, if it even has intentions. It simply offers phenomena and waits to see whether we are ready to understand them or willing to rest quietly within the mystery. Tonight, these visitors drift through our solar system like quiet thoughts crossing a vast mind. They neither approach nor retreat with urgency. They simply move in the ways that distant things move slowly, steadily, in soft dialogue with gravity and sunlight. It is all right to not know what they are. It is all right to observe without conclusion. The cosmos is in no rush, and neither should we be. As weeks passed and the visitors drifted farther into the inner solar system, the work of understanding them grew both more intricate and more delicate. Astronomers tightened their observations, refining trajectories with micro-arc second precision. With each update, the objects revealed subtleties no one had predicted: minor course corrections, faint changes in orientation, small but measurable adjustments that hinted at an inner logic. Whether that logic belonged to physics alone or to something more deliberate remained an open question. and open questions have a quiet gravity of their own. The VLBI network spanning continents, linking antennas separated by oceans, acted almost like a single planet-sized ear pressed against the void. From Earth's perspective, the visitors moved with slow, deliberate grace, yet their paths displayed hints of decision, of adaptation to changing solar conditions. Some argued that these maneuvers were no more than the product of radiation pressure acting on thin structures, surfaces calibrated to respond to sunlight with exquisite sensitivity. Others wondered whether natural radiation pressure could produce such consistent, such repeatable outcomes across so many distinct objects. Still, scientific caution held. Correlation is not agency, precision is not intention. The universe is capable of structures finer than anything humanity has yet imagined, forged in an environment so distant and extreme that our intuition falters long before the physics does. And so astronomers treated every anomaly not as a revelation, but as a question to be weighed slowly against the known laws of motion and light. But what challenged the community most deeply was not any single observation, but the pattern emerging from the ensemble. One object rotated like a panel, another like a needle, another like a rippling film. Their shapes were not only unusual, they were unusually varied. Natural debris tends towards certain geometries shaped by collisions and fragmentation, and the slow erosion of interstellar travel. These visitors, however, displayed diversity that defied simple categorization. It was as though each carried its own design, its own relationship to sunlight and thermal stress. Spectroscopic studies added more layers to the mystery. Some visitors showed organic rich surfaces, others bore signatures of exotic carbon allotropes, others reflected in ways that suggested thin metallic veneers. JWST glimpsed thermal spikes so narrow and so bright they resembled engineered reflections, yet even these phenomena could be explained by unusual crystalline structures or thin films formed under conditions humans have never replicated. Science has always walked between explanation and humility, and here humility seemed the safer companion. Meanwhile, radio astronomy continued its quiet vigil. The tones persisted. They drifted with motion, varied with approach angles, and maintained coherence unusual for natural emissions. Some objects broadened their signals into small bursts. Others shifted modulation slightly, as though responding to internal processes rather than external forces. Every variation was analysed, catalogued, debated. Every result yielded curiosity and restraint in equal measure. The public followed along with a kind of patient awe. Listening parties gathered around open fields and hilltops, tuning handheld receivers to the hydrogen line. University lecture halls overflowed with students eager to learn interference theory, orbital dynamics, radiative transfer. And throughout the world, a sense of quiet unity emerged, not because anyone understood what these objects were, but because the mystery drew humanity's attention upward again, away from familiar cycles, and toward the wider, older cosmos. What deepened the intrigue was the temporal reconstruction of Earth's own radio history. Researchers traced the journey of our electromagnetic signature across the galaxy, mapping the decades when our most powerful broadcasts would have reached nearby stars. They compared those eras to the estimated departure windows of the visitors. And though the correlations fascinated, many fascination is not proof. Human psychology leans naturally towards stories, patterns, echoes. The universe, however, does not guarantee meaning in the places where we search for it. Some scientists cautioned against the look elsewhere effect. With enough data points, coincidences become unavoidable. With enough variables, alignments appear inevitable. Yet others insisted the correlations deserved attention, not as evidence of communication, but as phenomena worthy of careful study. In the silent cosmos, even coincidence can become a meditation on scale and time. The debate grew into a gentle tug-of-war between caution and curiosity. Conferences filled with quiet disagreements, each grounded in respect for the unknown. Philosophers joined discussions on pattern recognition. Statisticians examined the probability space. Astrochemists weighed in on formation scenarios for exotic materials. It was not a disagreement about conclusions, but about how to approach a question unprecedented in human history. And through all of this, the objects continued their slow choreography through the solar system. Their signals remained steady, Their rotations remained consistent. Their paths remained precise. No sudden maneuvers, no abrupt behaviour, only a quiet, continuous unfolding of data that asked humanity not to leap forward but simply to watch. It is in such watching that science finds its depth. The certainty that once guided exploration has long since given way to a gentler truth, that the universe does not reveal itself in answers but in layers. That knowledge arrives slowly like starlight crossing distances too vast for thought. That humility is not a weakness but the natural state of any mind standing before the cosmos. Tonight these interstellar visitors drift through our awareness like distant thoughts. They ask nothing of us. They promise nothing. They simply move across the dark shaped by forces older than memory, older than worlds. And we small observers on a small planet look upward and try to listen. It's all right not to understand them yet. Some mysteries are not puzzles, they are invitations. Tonight the universe whispers again, "Sleep now, traveller. The cosmos will keep watch." As the months unfolded and the data deepened, humanity found itself confronting something it had never rehearsed in any textbook nor fully imagined in any observatory meeting. The dawning realization that if these visitors were aware of us, then they had been aware for far longer than our senses had known them. This understanding did not arrive in a single revelation, but through gradual reconstruction, a slow layering of physics, history and patience. Scientists began tracing Earth's electromagnetic past, decade by decade, mapping the faint bubble of our radiated presence that now stretched more than a century outward in every direction. It was a fragile sphere, faint and thinning with distance, yet undeniable an expanding echo of humanity's inventions drifting across the interstellar medium. The early decades of this bubble were almost shy, filled with weak television signals and scattered radio transmissions leaking unintentionally into space. Later years grew louder. Planetary radars, military arrays, deep space commands. A handful of observatories investigated whether any star systems intersected with these outward-moving waves at precisely the right times to detect us. A few alignments stood out. The numbers were clean, but numbers alone cannot bestow meaning. They simply show what could be true, not what is. Yet it stirred contemplation. If any distant world had noticed Earth's accidental broadcasts, they would have noticed not a message but a presence. Not a greeting, but a noise humanity revealed not through philosophy but through interference. And so the thought settled quietly across the scientific community. If a listener existed, they would have known we were here, long before we knew to wonder whether they were. But speculation remained a fragile bridge, and the astronomers refused to cross it without evidence. They reminded one another that the universe is not obliged to match human narratives. Transmission bubbles expand, signals weaken, coincidences arise naturally in large datasets. It is natural for the mind to seek purpose in patterns even when the patterns are indifferent. And so the community maintained its equilibrium, curious but anchored, open but unassuming. In the wider world, however, the awareness that humanity's voice had been drifting for more than a century provoked a subtler transformation. People began to think in longer timescales than their own lives. They spoke about their great-grandparents' radio shows as accidental messages carried into the dark. They imagined distant worlds receiving fragments of baseball commentary, sitcom laughter, weather alerts, and orbital radar sweeps. The thought was strangely intimate, the idea that humanity, without intending to, had left a trail of faint lights across the galaxy, like a species whispering in its sleep. And as Earth contemplated what it meant to have been heard, a different shift occurred, one not in data but in internal landscapes. Psychologists and sociologists noted a rising sense of calm curiosity among communities that gathered to discuss the visitors. Support lines reported an unusual blend of existential awe and quiet reassurance, as though the possibility of distant listeners softened something that had long felt sharp. The universe once imagined as empty suddenly felt inhabited, not crowded, not threatening, but alive. Religious communities began their own reflections. Some found comfort in the idea that creation might be deeper, more populated, more magnificent than previously imagined. Others reflected that if intelligence exists elsewhere, it too must grapple with questions of origin, purpose, and meaning. The idea that human experience might be one thread in a larger tapestry settled gently into consciousness, not as a disruption, but as an expansion. Even the economy responded, though economics is rarely poetic. Aerospace investments fluctuated as markets tried to forecast the significance of the visitors. Companies released products, and marketing campaigns infused subtly with cosmic imagery. And yet behind the surface reactions, a quieter shift occurred. People began to think in centuries. Plans for infrastructure, education, science, and culture took on longer horizons. Humanity found itself nudged almost imperceptibly toward a larger sense of time. But perhaps the most striking transformation took place in how people interacted with the night sky itself. Observatories became pilgrimage sites. Families drove hours to stand beneath rooftop domes where telescopes tracked the faint glints of the visitors. Students gathered on grassy hillsides with laser pointers and star charts. Cities dimmed lights for dark sky events. In these gatherings there was no fear, only shared curiosity and ancient instinct rekindled. Even those who felt unsettled by the implications found themselves drawn to the sky, staring upward, as though looking for reassurance in the quiet arrangement of stars. The idea that the universe might contain other minds did not diminish human meaning, it expanded it. People described feeling both smaller and more connected, as though scale had revealed not insignificance, but belonging. Through all of this, the visitors themselves remained unchanged. They drifted past Mars, past the orbit of Earth, gliding, with an indifference that felt steady rather than ominous. Their signals continued. Their rotations persisted in their peculiar rhythms. Their surfaces reflected sunlight in ways that puzzled but did not threaten. They were objects of inquiry, not omens. They did not approach Earth nor deviate toward any inhabited world. They simply passed through, leaving behind data and questions and a gentle rearranging of human perspective. And so, humanity found itself living within a paradox, caught between the discipline of scientific caution and the quiet emotional resonance of cosmic companionship. No one claimed answers, no one pretended certainty. The mystery remained intact, unbroken, untouched by premature conclusions. And perhaps that was the greatest gift of all, the space to wonder without rushing toward resolution. Tonight, these distant travellers continue their silent passage. Their signals remain faint, steady, unchanged. Their paths cross our awareness, but not our world. And in their motion, humanity has discovered not fear, but reflection, an invitation to consider itself within a larger story, one still being written in starlight. It is all right not to know what comes next. Some questions are meant to accompany us gently into the dark. Tonight the stars keep their silence. Sleep now, listener. The cosmos is awake for both of us. As the visitors moved deeper into the inner solar system, another question began to take form, not in press briefings or public speculation, but in the quiet corridors of observatories, where red lights glowed over desks and researchers whispered across screens. If these objects were not merely passing through, but were themselves instruments of observation, then the natural next step for humanity was to decide whether and how to answer them. Yet the question was not simply technical. It was philosophical, ethical, and profoundly human. Radio astronomers had spent decades preparing for a moment they never truly expected to arrive. Protocols existed, guidelines written in measured language, carefully debated across international panels, but these documents had been crafted for one scenario alone: a distant static radio source announcing itself with a simple, unmistakable beacon. They were not built for visitors moving through the solar system, emitting narrowband tones while reflecting sunlight in strangely coherent geometries. They were not built for an encounter that felt both close and indefinitely distant, both immediate and inscrutable. Still, the scientific community approached the possibility of a reply with its characteristic restraint. They reviewed the protocols line by line, not to follow them rigidly, but to understand where they remained relevant and where they failed to anticipate the complexities of this moment. The first principle held firm: no nation, no institution, no agency should answer alone. If humanity was to speak, it must speak as one. And in that quiet insistence on unity, something rare began to take shape. Researchers from different countries, sometimes accustomed to competing for telescope time, found themselves sharing data more freely than ever before. Meetings that once ran on tight schedules now lasted deep into the night as scientists compared Doppler drift patterns, signal-to-noise ratios, orbital predictions, and statistical models for natural versus artificial origins. The conversations were not driven by urgency but by the gravity of the unknown. No one wished to rush. No one wished to misunderstand. The tone was cautious, reverent, and almost tender. Outside those circles, humanity prepared itself in different ways. Some communities held gatherings where people simply sat under the open sky, speaking softly about their hopes or their uncertainties. Children asked whether extraterrestrial beings might hear the songs played on the radio. Adults, who often believed themselves immune to wonder, found themselves pausing before answering, realizing that for the first time in human history, such questions could not be dismissed outright. In the scientific world, the preparation remained grounded in methodology. Before humanity could consider transmitting anything, researchers had to understand the incoming tones as clearly as possible. They began analysing the narrowband carrier, not as a message but as a signal source, its modulation depth, its harmonic structure, its drifting stability. They mapped the subtle fluctuations in frequency and amplitude, searching for whether these variations reflected internal mechanisms of the object or interactions with the solar wind. They asked not what was being said, but how the tone behaved, not for meaning, but for physics. Some of the fluctuations suggested a relationship to the object's rotation, as though the source of the signal was mounted on a structure that moved in and out of a line with Earth's sensors. Others hinted at thermal effects, small changes in amplitude appearing as the object absorbed and re-radiated sunlight. Even the simplest elements of the signal carried layers of interpretation, and scientists approached each layer with the same patience they would bring to studying a star's magnetic cycle or a pulsar's spin-down rate. Yet something else began to emerge, not from the data alone, but from the convergence of so many independent observations. The objects maneuvered not dramatically but subtly, coarse adjustments too small to constitute evasion or approach, but too consistent to dismiss as random. Over weeks and months, these adjustments lined up in ways that maintained visibility from Earth's major radio observatories. If this was coincidence, it was a coincidence that unfolded with a strange, persistent grace. The possibility of responsiveness not as communication, but simply as awareness, became a subject of careful analysis. Researchers compared timestamps from transmissions sent by Earth with any subtle changes in the object's signals or orientations. Most comparisons revealed nothing. A few revealed patterns that were tantalizing but inconclusive. The boundary between signal and noise grew thinner, and astronomers moved with caution to avoid stepping across it too quickly. Science thrives where uncertainty remains intact. What made the moment extraordinary was not the prospect of contact, but the collective restraint with which humanity approached it. There was no rush to transmit, no desperation to be understood, no clamour to proclaim intention. Instead, there was reflection and almost meditative awareness that to speak across the stars, even tentatively, required not confidence, but humility. And so humanity waited, not in fear but in thought, not in confusion but in curiosity. The visitors drifted on silent, except for their faint tones neither nearing Earth nor retreating from it. They existed in a strange equilibrium, present yet distant, perceivable yet unreadable. Their passage through the solar system became less of an event and more of a phenomenon, something to observe without expectation, like a rare alignment of planets or the dim flare of a supernova on the horizon of the Milky Way. The patience in its own way became a form of communication, an acknowledgement that the cosmos is older than urgency, deeper than panic, and quieter than any human fear. In watching the visitors glide past, humanity discovered that the first step toward interstellar dialogue might not be to speak, but simply to listen without demanding answers. Tonight, the objects continue their silent trajectories, carrying their mysteries beyond the reach of our instincts, but not beyond the reach of our awareness. Their signals remain steady. Their paths remain smooth. Their presence remains gentle. It is enough for now to know they pass through our sky. It is enough to wonder without conclusion. Sleep now, traveller. The cosmos is still listening and still at peace. As the possibility of a reply lingered in scientific discussions, another realization gradually took hold Less dramatic than any headline, yet more transformative than any single piece of data, humanity was beginning to understand that these visitors, whatever their true nature, were not confronting us with a demand. They were not issuing instructions nor signalling urgency, nor performing maneuvers that suggested threat or intention. Instead, they moved with a kind of serene indifference, like drifting fossils of a long-forgotten civilization, or instruments built for purposes far larger than any small world's comprehension. And in this indifference, there was something strangely comforting. It reminded scientists of a truth they had always known, that the cosmos does not revolve around human significance, and that humility is not a concession, but a perspective. As researchers studied the faint signals, they understood that the deeper value lay not in extracting meaning, but in observing their stability. The tone's constancy became a sort of cosmic metronome, a calibration point between expectation and wonder. It was the simplicity of the line that made it difficult to dismiss and equally difficult to interpret. No obvious message, no encoded bursts, no artifacts of modulation beyond those accounted for by motion and temperature. And yet its persistence refused to disappear into randomness. It remained at the edge of certainty, like a photon whose behaviour defies categorization until measured. Scientists found themselves speaking not of conclusions, but of likelihoods, not of answers, but of boundaries. In the midst of their caution, something beautiful was happening. Disciplines that rarely intersected, astrophysics, signal processing, philosophy of science, cognitive psychology, began engaging in shared dialogue. The question of what it means to interpret a signal became a cross-disciplinary meditation. Psychologists studied humanity's instinct to seek patterns in noise. Philosophers discussed the nature of meaning in a universe indifferent to interpretation. Astrophysicists refined models of non-gravitational motion. Statisticians recalibrated how significance thresholds should be applied to unprecedented datasets. The mystery did not divide fields, it braided them together. Meanwhile, the objects continued their measured glide, interacting subtly, with solar radiation responding gently to gravitational tides, shedding hints about their composition, with each thermal fluctuation. They behaved not as emissaries, but as wanderers. Yet the precision of their wanderings challenged that description. Courses, adjustments, small, graceful, almost unnoticeable, seemed calibrated to maintain visibility across multiple observatories as Earth rotated. The behaviour could be natural, or it could be something more. Scientists refused to assume either. Restraint became the discipline that carried them forward. Outside the research community, humanity adapted to the unfolding mystery in softer, more personal ways. Couples walked to quiet hillsides after dinner to look for faint streaks of reflected sunlight. Teachers brought portable radios to classrooms so students could listen to the static near the hydrogen line, knowing they would hear nothing distinguishable but wanting the students to feel part of something larger. Museums opened evening exhibits about interstellar objects, emphasizing not their strangeness, but their rarity and beauty. Across the world, people found themselves speaking more gently about the sky, less as a distant unknown, and more as a shared environment like an ocean we're only beginning to sail. What surprised sociologists most was the effect on human conflict. In regions typically divided by political or cultural lines, gatherings formed to share telescopic views, to compare amateur observations, to discuss theories with the same soft curiosity. The sense of collective wonder transcended boundaries. It did not erase differences, but it softened them. For a moment, humanity's divisions felt smaller than the silent visitors drifting through the solar system. And still, through all the public fascination, the scientific community maintained its slow, methodical pace. They refined orbital models. They recalculated trajectories. They looked for perturbations that might distinguish natural forces from micro-engineered adjustments. They monitored the narrow band emissions with increasingly sensitive instruments, tracking every microhertz drift. They remained steady in the face of uncertainty, refusing to let speculation outpace evidence. Gradually a new understanding took shape, not of what the objects were, but of how humanity must approach phenomena at this scale. The visitors did not require reaction. They did not demand interpretation. They did not compel humanity to speak or respond. Instead, they revealed that curiosity could exist without urgency, that silence could carry meaning even when meaning was unknown, and that the desire to understand need not lead to hasty conclusions, it became clear that the first step toward any genuine interstellar consciousness would not be technology, nor mathematics, nor communication protocols. It would be patience, the kind of patience that accepts unanswered questions. The kind that understands knowledge is not a destination but a path illuminated slowly fragment by fragment. The kind that respects the cosmos enough to wait for clarity rather than invent certainty. Night after night, the visitors grew fainter as they moved outward again, leaving the inner solar system behind. Their signals weakened as distance stretched their coherence. Their reflections dimmed as sunlight fell off in inverse squares. Their trajectories bent gently under the pull of the sun, then loosened as they approached the threshold, where gravitational bonds give way to interstellar freedom. As they receded, they left behind not explanation but perspective. They reminded humanity that intelligence, if it exists elsewhere, is not obliged to declare itself, that mystery is not a void but a presence, that the universe is vast enough to hold countless truths, some of which will never arrive in forms we expect, and that even without answers, wonder is a worthy companion. Tonight the objects drift beyond the edge of our most sensitive telescopes. Their tones fade into the noise floor. Their light curves flatten into invisibility. Their presence dissolves into the cosmic background. But the awe they inspired remains quiet and intact. It is enough to have witnessed them. It is enough to have wondered. Sleep now, listener. The universe will continue its long, patient conversation with or without interpretation. As the visitors drifted toward the outer reaches of the solar system, their presence began to shift from something observed to something remembered. They had become part of our scientific record, yes, but also part of the quieter landscape of human thought. Their trajectories, once the focus of daily updates and sleepless nights in observatories, now evolved into long, slow arcs of departure, almost gentle in their inevitability. The tones they had emitted grew fainter with distance sliding beneath the sensitivity thresholds of even our most carefully calibrated instruments. Yet their fading did not feel like loss. It felt like the natural consequence of any encounter shaped by astronomical scales arrival attention and then return to silence. Researchers continued to comb through the months of accumulated data, finding patterns subtle enough to escape initial scrutiny. Tiny variations in surface reflectivity suggested layered structures. Minute timing offsets in radio drift hinted at thermal cycles stranger than any modelled for natural bodies. But each anomaly, once isolated, carried its own universe of interpretations. Some could be explained by complex but natural processes, outgassing without obvious coma microfractures, responding to solar heating, crystalline materials undergoing phase transitions at unexpected temperatures. Others resisted easy categorization, but resistance is not confirmation. In science, the unknown is not evidence of the extraordinary. It is simply an invitation to learn more. Observatories that had once been filled with urgent speculation now found themselves in a different rhythm, a reflective one. Astronomers spoke quietly about uncertainties and edge cases, about how new classes of interstellar objects might force a revision of long-standing assumptions. Signal analysts cross-checked subtle frequency modulations against models of plasma interactions. Material scientists discussed exotic carbon lattices that might form in environments no human has yet imagined. And philosophers, with their own gentle precision, examined how humanity might live with mysteries that offer neither closure nor threat. The shift from excitement to contemplation was almost imperceptible. At some point, the idea that these objects might be intentional visitors grew less dominating, not because it had been disproven, but because the need for a definitive narrative softened. People realized that ambiguity could coexist with wonder. The visitors did not need to be emissaries or probes or relics of an ancient intelligence. They could simply be what they were, phenomena moving through the solar system, carrying meaning shaped not by intention, but by observation. Yet even without resolution, their passage left subtle traces across human culture. Linguists noted the quiet emergence of new metaphors, comparisons between relationships and orbital paths, between silence and narrow band signals, between departure and hyperbolic escape trajectories. Poets wrote about the dignity of objects that pass through without explanation. Musicians sampled the faint hum near the hydrogen line and wove it into compositions meant to be played late at night in dim rooms with slow breathing. In classrooms, children asked not whether the visitors were alien, but why objects travel so far, why gravity curves space, why light takes time to move. Teachers found themselves drawing diagrams of orbital mechanics, explaining the elegance of eccentricity greater than one introducing young minds to the quiet poetry of trajectories that do not return. In this sense, the visitors had accomplished something profound. Without ever needing to be understood, they had made the universe feel alive again. Scientists often describe their work as building models of reality, yet the visitors revealed something deeper, that science is not merely a method for acquiring answers, but a framework for embracing uncertainty. Each unexplained detail became less of a threat to knowledge and more of a reminder that the cosmos remains larger than our theories, older than our instruments, and richer than our assumptions. The recognition did not diminish human intellect, it anchored it. As the visitors slipped toward the heliopore's Earth's deep space, antennas continued listening long after logic suggested the signals would fade completely. The act of listening became symbolic, a gesture of patience rather than expectation. The faint static at the hydrogen line, once examined with intense scrutiny, now became a kind of cosmic lullaby evidence not of communication but of continuity, the steady background breath of the universe. In the academic world, a new field quietly began to take shape: interstellar object studies. Researchers proposed missions designed not to intercept, but to observe future visitors with gentler confidence. There was no rush, no expectation of answers. Only the understanding that the cosmos would send more wanderers, eventually some familiar, some strange, each carrying another fragment of the universe's silent story. And humanity, now practiced in patience, would be ready to watch without demanding revelation. Even policy discussions, once consumed with hypothetical scenarios of contact, began to soften. Governments realized that not every unusual object warrants reaction. Some simply warrant observation. The notion of planetary diplomacy, once a speculative concept, evolved into a gentler principle that if humanity ever sends a deliberate transmission into the cosmos, it should be sent not out of urgency, but out of understanding. Not as a request, but as a reflection. In time, the visitors became part of Earth's folklore, not as myths, but as science remembered with calm affection. People would speak of the summer when multiple interstellar objects passed through the inner solar system, each one carrying puzzles we had not solved and questions we had not yet learned to ask. They would recall how humanity stood beneath the night sky, with renewed curiosity, how children traced the arcs of their paths in notebooks, how radio enthusiasts pointed antennas toward the void, listening for tones that never grew louder but never entirely disappeared from memory. And though the objects themselves slipped beyond detection, their presence lingered in the way anyone who had lived through the event began to think about the night sky not as a distant ceiling, but as a realm in motion, alive with travellers who come and go without explanation, without purpose and without malice. Tonight, somewhere far beyond Neptune's orbit, those visitors continue their journey untouched by human expectation, unshaped by human meaning, simply following the unbroken logic of physics. They drift into darkness with the same neutrality with which they arrived, leaving behind a world that has grown slightly quieter, slightly wiser, and slightly more attuned to the silence between the stars. It is enough to have watched them pass. It is enough to have wondered. Sleep now, traveller. The cosmos remains vast, patient, and endlessly unfolding, and so as the last traces of their trajectories dissolve into the outer dark, we are left not with answers, but with a deeper stillness and understanding that the universe does not reveal itself through certainty, but through the quiet privilege of witnessing its passing wonders. The visitors have moved on, yet the questions they stirred remain soft and persistent, like after-images of starlight on the retina. In their silence, we discovered our own capacity for patience. In their mystery, we rediscovered the humility that science and sleep both require. Whatever they were, natural wanderers or something more deliberate, they reminded us that to observe is enough, to wonder is enough, and to rest beneath an unending sky is its own form of belonging. Tonight the cosmos keeps its gentle watch, and we small observers on a drifting world can finally breathe drift and let the silence cradle us into sleep. Traveller, As our story drifts toward its quiet end, let your mind rest in the soft truth we uncovered together tonight. 3 Atlas came and went like a thought the universe whispered to itself, brief, brilliant, and impossibly far from ordinary. And though we cannot say whether we summoned it, or whether it was always on its way, its passage changed the way we look at the sky. It reminded us that even in the silence, something may be listening. Something may be watching with the same curiosity we feel in our deepest, stillest moments. Observer, the mystery is not over. It never was. The cosmos does not reveal itself in full. It opens only in fragments, small glimmers of understanding drifting through centuries like dust in a beam of light. What matters is that you are here to witness one of those glimmers, and that you carry its wonder gently into your own night. We are small, yes, but not forgotten, not lost. Every question we ask becomes part of the long unfolding conversation between matter and mind, between star and seeker. And sometimes, as with 3i Atlas, the universe answers in its own quiet language. So rest now, listener. Let the questions fade into the dark where they belong for the moment. The stars will keep their silence. The cosmos will keep its watch. And if this story found you tonight, traveller, you are welcome to return for the next. Rest well. Stay curious. The night is long and full of wonder.